So, section 1-2 in Algebra 2 here, about algebraic expressions. So, I'm asking you to follow the order of operations. If you can follow the order of ops, we are in good shape. If you can't follow the order of operations, then we really need to practice, because that's a skill we definitely need in Algebra 2. So if you're given this expression, and then you're told that a and b are equal to 3 and negative 1, then you need to substitute these values in. Order of operations, from left to right. I can't do anything inside the parentheses. There are no exponents, so I've got to go through and do multiplication from left to right. So we have 3, 2 times negative 1 gives me negative 2, and 3 times negative 1 gives me negative 3. So now I'm going from left to right with addition and subtraction. 3 minus 2 minus negative 2, that becomes a plus. That's 5, and then a minus 3 gives me 2. Okay? Or maybe another example that involves parentheses and exponents. And I changed up example 2 to include a negative value because I see a lot of kids who refuse to use parentheses around something before it gets squared because they think, oh, those two negatives should cancel out. Big time no-no. Okay, the red pen of death is going to hammer that one, and we do not want that to happen. So make sure you're careful with that. So I've substituted in a following order of operations, which says parentheses. I see I've got a negative 2 over here times. That would be a negative 2. And I also have an exponent to worry about. And if you are concerned about it, make sure you know how to use your... let's use a different calculator than that one. So I'm going to go get a different calculator while you are just twiddling your thumbs because you're waiting for me to get my other calculator. Even though you can barely hear my voice, as I move away from the microphone, and now I'm coming back and you can hear it loud and clear. Alright, so we're going to use this other calculator because it's got a better screen. Because somebody scratched up the other one and it looks nasty. Okay, much better. Okay, so we've got negative 3 squared. So that's 9. I promise you, if you do not use the parentheses, like I'm telling you, you will get the wrong answer. Okay? So this part right here is 9, and then of course we've got the negative that goes with it from the front. And then we have negative 2 times negative 2, or positive 4. Now I can add from left to right, giving me negative 5 for my answer. Okay? Use that calculator to help you get, or use parentheses around negative values when you're raising them to a power. Okay? So if we take a look at example 3 from the book, see if I can back up a little bit here so you can see the whole thing. Okay, so let me read through this problem. The expression negative 0.3y plus 61 models the percent of eligible voters who voted in the presidential elections from 1960 to the year 2000. In the expression, y represents the number of years since 1960. So if I put a 0 in there, that would really be the same as the year 1960. Find the approximate percent of eligible voters who voted in 1988. Well, the big thing we have to realize or figure out is how many years after 1960 is 1988. So we're going to take 1960 minus, sorry, I had to scribble here, so minus 1960 to find out that there are 28 years after 1988 is 28 years after 1960. So this is what we're using for y. So we are going to replace the y with 28. And then we can use our handy dandy machine. Negative 0.3 times 28 plus 61. And so, using our handy-dandy machine in the order of operations, we get 52.6. 52.6. And that is the percent of eligible voters. So as you can tell from that particular problem, the percent of eligible voters has been going down. Okay? Not a great thing, is it? I want you to kind of look at a couple things that are in the textbook here. And I'll switch it over so you can see the color. Because I really want you to understand that the word term is a number, a variable, or the product of a number and one or more variables. So 7x squared is a term. 3y is a term. Okay, so it can even have more than one variable, right? Like 3xy to the third, that's one term. But you can have something as simple as -2. That's a term. Or b, that's a term. But this whole thing right here, 7x squared plus 3y, is not a single term. Okay, that's two terms that are being added together. So when we think of a single term, we use the word monomial. Right? When we think of two terms, we call it a binomial. When we think of three terms, we call it a trinomial. Okay? But we can talk about that later. A single term. Coefficients. That term, that word means the number that's being multiplied times. So the coefficient here is 7, and the coefficient here is 3. It's the number being multiplied times the term. Now, if you don't see anything, like, well, this one is a -1. This one right here has a coefficient in front of the a right there of 1. If we don't see it, we know it's a 1 because it's being multiplied. Now, there are things called like terms. In order to be a like term, it has to have the same variables and the same exponent. So, for instance, this is r squared and that's r squared. Those have the same variable and the same exponent. Therefore, these are like terms. So, if I have 3r squareds and I take away 1r squared, that leaves me with 2r squared. These are also like terms because I see that they have the same variables and the same exponents. So if I have -2 of these xy cubes and I add 3 of these xy cubes, that leaves me with 1 xy cubed, right? Because it's basically like saying 3 minus 2. Now, there's a whole list of properties that I'm going to quickly go through. All right, and I can switch back to the negative now so it's easier to see. Subtraction, I'm just going to read through these because I know that they're easy for you to understand, okay? Subtracting a positive is like adding a negative, okay? Division. Division is the same as multiplication by the reciprocal. Remember you had things like keep, change, flip? Keep, change, flip. So you keep the first one, change it to multiplication, and flip the second one and make it a reciprocal. Okay, we've done that before in middle school, so it should be distributing. Distributing works across addition and subtraction. So you can take. Now, one thing I want to point out to you here that you may or may not remember is distributing. A lot of kids think of the distributive property as when you take something on the outside and multiply it times all the things on the inside, which is true. But did you also realize that you can look at something like this and see a common factor and pull it outside the parentheses? That's working backwards, using the distributive property backwards. And a lot of kids do not realize that that's what they're doing, or that that's even legal, or that that's the property that they are using. But that's it. It works in either direction. We also know that when you multiply by 0, you get 0. When you multiply by -1, you get what's called the opposite. The opposite of a sum, well, that's the same thing as distributing a -1 and then adding things up. Or the opposite of a difference, distribute a -1, which changes the sign of everything on the inside. Now, they happen to try to get tricky on us. Instead of writing -a plus b, they decided to switch it around and write b minus a. Same thing. The one thing that I need to point out to you is the opposite of a product. When you have the opposite of two things that are being multiplied, it is not -a times -b. Because that would completely change the sign. It's -a times b or a times -b. You can distribute the negative to 1, but not both. And that's different from, say, maybe the opposite of a sum or the opposite of a difference, where you distribute it to both. When you're distributing it to a product, it only goes to 1 if you want it to stay the same. The last one is called the opposite of an opposite, but that's pretty easy. The opposite of a negative value is a positive value. It's not a big deal, and I'm pretty sure you all know that. Okay, adding like terms. So if I have 3k and I take away 1k, that's obviously equal to 2k. Now, when I see things like this, and I'm trying to add like terms, I actually use a little bit of my kindergarten days, maybe first or second grade, where you line things up in like columns, and then you add down those columns. So 5z squared, take away 8z squared is -3z squared. -10z plus 1z is -9z. So I'm treating this, and remember, these are not equations. These are not equations. I'm just asking you to add like terms. Okay, there's no equal sign. There's nothing thrown on the other side. There's not solving like you would do in Algebra 1. We'll get there. Okay, it won't be that long. So I'm going to distribute the negative there and get -m plus n plus, and then I distribute the 2 and I get 2m minus 6n. Then, of course, since I'm adding like terms, I'll just put them underneath of each other, and I will add them in vertical column fashion. So that is -1m plus 2, that makes 1m, and -6 plus 1 would make -5n. Okay? Example 5 is a perimeter question. So in example 5 they say add up the sides, right? That's what perimeter is, adding up all the distances around the outside edge. I got a trick for you on this. Instead of writing 3x and 2x and 3x minus y and 1y and 1y and a 2x minus y, you could write out all the sides and add them all up. I don't know if you see this, but all those cancel out. You have 3x, 3x, 2x, and 2x. So 6 and 4 makes 10x. But here's what I want you to see. What if you took this side right here and you just slid it down, right? Slid the whole thing down and you put it right here. And then you took this side and slid it over to the left and you put it right here. Wouldn't you create a rectangle? And what's the length of this side? Well, doesn't it have to be 3x? What's the length of this side? Doesn't it have to be 2x? So isn't that 2x plus 3x plus 2x plus 3x? So in other words, make it into a rectangle. And then it's a lot easier to see. Don't mess around with the minus y's here and the plus y's there. You don't need to worry about that. You'll get the same perimeter if you decide to do it that way as if you use my little trick. But I will say this, it does come in handy when you're looking at stuff on the SAT. If you decide, instead of messing with 6c minus 2d over 3 and 3c minus 1d over 3, if you decide to move this side down, completing that side right there, realizing this side from here to here is 3c, I've got a 3c and a 3c and a 2c and a 2c. So that would be 3 plus 3 is 6, and 4 more is 10c. Now, I do realize that you have two d's right there. So, my final answer is going to be 10c plus 2d. You can't forget that you only moved one of the sides. You did leave two of them in there, and so that would be your perimeter. So I can use that little trick, and it still helps me simplify the whole process instead of getting all complicated with the fractions, which I'm sure none of you would like to mess with anyway. Okay, those are my notes for today.